Good morning to all. I am Sophia, Assistant Professor, Department of Physics, Sakti College of Arts and Science for Women, Ottanjatram. Today topic linear vector space. Vector in a three-dimensional space. A vector in three-dimensional is a physical quantity having both magnitude and direction. A vector of magnitude 1 is called a unit vector. To represent an arbitrary vector, we introduce unit vectors, say e1, e2, e3, along the positive direction of the right-handed system O, X, Y, Z of three mutually perpendicular axes. Then any vector A can be expressed as A equal to A1, E1 plus A2, E2 plus A3, E3, where a1, a2, a3 are scalars. Given a vector A, the scalars a1, a2, a3 in equation 1 are uniquely determined. The unit vectors e1, e2, e3 are said to inform a basis for the set of all vectors in three dimensions. We say that e1, e2, e3 form an orthonormal basis. The scalars a1, a2, a3 in equation 1 are the components of A in the basis e1, e2, e3. Represent A as a column vector A equal to a1, a2, a3. The component of e1 are 1, 0, 1, e2 equal to 0, 1, 0, e3 equal to 0, 0, 1. Totally of vectors of three dimension is called a three-dimensional space. Given two vectors A equal to a1, a2, a3 and B equal to b1, b2, b3, equation 4. In these spaces, the scalar product or inner product of A and B denoted by AB. AB is defined as AB equal to summation of 3 I equal to 1 AIBI. Vector in an n-dimensional space. Now generalize this concept to an n-dimensional real space with the vectors e1, e2, en forming an orthonormal basis. A vector can be expressed in this orthonormal basis A equal to summation of n I equal to 1 AIEI. The totality of all n-dimensional vectors is called an n-dimensional space. Simply an n-vector space. In this space, the inner product is defined as AB equal to summation of n I equal to 1 AIBI. If the vectors are complex, that is if the components of the vectors are complex numbers, the inner product is defined as AB equal to summation of n I equal to 1 AI star BI, where for any complex number Z star denotes the conjugates. For any vector A comma A equal to summation of n I equal to 1 AI star AI equal to summation of n I equal to 1 AI modulus of squared. Define the norm n of a vector A by capital N equal to A comma A the whole bracket 1 by 2. A vector whose norm is unity is said to be normalized. The normalized vector A comma A equal to summation of n I equal to 1 AI star AI equal to summation of n I equal to 1 AI modulus of squared equal to 1. Two vectors A and B are said to be orthogonal if A comma B equal to 0. Using the concept of inner product, the vectors a1, a2 form an orthonormal set. Ai, aj equal to del ij, I, j equal to 1, 2. where del ij is the Kronecker delta defined by del ij equal to 1 0 if I equal to j, 0 if I not equal to j. If an n-dimensional space, a set of n vectors a1, a2, an are said to be linearly dependent if there exist scalars c1, c2, cn not all 0 such that summation of n I is equal to 0, ci, ai is equal to 0. The vectors are linearly independent if no relation of the form equations 15th unless c1 equal to c2 equal to up to cn is equal to 0. N-dimensional space and any vectors by which lies in the space can be expressed in the form by equal to summation of n I equal to 1 ci ai. The generalizations of these components to an infinite decimal space called vector space is straightforward. Thank you.